all you're going to look for is the x value where your graph crosses the x-axis. Solving your quadratic equation by graphing. Basically what we'll do is instead of setting it equal to 0, well, we'll set it equal to 0, and we'll, bless you, do what we call graph the related quadratic, which just means we'll do y equals whatever our quadratic equation is when it's set equal to 0, and then you can actually find the zeros on the graph, and that'll be the answers to that equation. So I just have these first 3 problems. They're literally already done for you. So these just each have graph of a parabola on there, and it just asks you to find the solution. So all you're looking for is where does that graph, actually I should say, let me back up here. This says crosses, I'm going to say or touches. It might not actually go through the x-axis. So if it goes through the x-axis or if it touches the x-axis, that's the x value that you're going to look for. So if I look at this first lovely parabola, can you tell me what the zeros are? Eli, what do you think? Just right here, 4, 8, and you don't have to write them as a point here, like 4, 0, 8, 0. You don't need to write them as a point, but basically we're solving by graphing. All you're going to look for is just where does this cross or touch the x-axis. If it helps you in any way, maybe highlight the x-axis and see if that helps you see it better. What would your answer be for the second picture? Just 6. Now, it can have a situation where you just touch the x-axis. That's why I went back and added that to that definition. This would just have 6 as an answer. All right, what about the last one? Doesn't touch, right? Okay, now, we're going to get into this a little bit later in the unit, but I'm going to write there's no real solution. That would have an imaginary solution, but for our purposes right now, if it doesn't touch the x-axis, it doesn't have a real solution. All right, does anybody have a question if you got the graph in front of you? Okay, so this will be a little throwback to our last unit. I'm going to ask you, I'm going to give you an equation, right? These are both set equal to 0. This first one is in what I would call standard form, ax squared plus bx plus c. What we're going to do, and don't write this on your paper, but we're just going to graph y equals x squared minus 4x minus 5. And when I graph it, all I'm looking for to make y 0 would be where the graph crosses the x-axis, just like those other questions. We're just going to graph this one by hand. So, does anybody remember, because I want to find the vertex. How do I find the vertex if I have standard form? Plus. Okay, so negative b over 2a. Can't see the vertex in standard form, so you have to find it. So we're going to do negative b over 2a and then plug in whatever that number is for x to get our corresponding y value. So for this lovely question, my b value is negative 4. So it would be positive 4 for the opposite of b, or negative b over 2a, which would just be 2 times 1 here. Bless you. So it'd be 4 over 2, which is 2. Then I'm going to plug in 2. So I'm going to do 2 squared minus 4 times 2. You feel free to use your calculator if you want to. This would be, let's see, 4 minus 8 minus 5, so negative 9. All right, so my vertex to negative 9. All right, now, if you got the vertex, the only other thing you need is the a value, and then you can write down what the pattern would be to graph the points. Now, what is my a value here? So what's my pattern? Just 1, 3, 5. All right, now, this one, and remember, this just goes by odd numbers, so if you needed it to, like 7, 9, you could keep going. But in this situation, you're going to have to graph enough of the parabola that it either touches the x-axis or crosses the x-axis. So you might have to go farther into the pattern depending on where your graph has its vertex. This one we should be okay, I think. If you go to 2, negative 9, oh my goodness, I had to scooch this up a little bit. It's at the very, very bottom of the graph here. There's 2, negative 9. So just over 1, up 1 on either side, over 1, up 3, and then, hey, if you guys want to look at that right there, right, if you look back at my lovely equation there, my y-intercept should be the constant term, right, negative 5. Guess what? That's where it crosses. the y-axis, so I could kind of check my graph a little bit by looking at that. Now, to get my actual answer, I got to get it up to the y, or the x-axis. So your 5 should be 2 nice points on the x-axis. So the answer to the question there, I'm literally just looking for the solutions. I'm not going to write these down as coordinate points because we're just graphing the related parabola to answer the equation that I had at the beginning of the problem. So you just write down those 2 x values for your answers. So I would write down -1 and +5. Both of those are answers there. So that's standard form. Does anybody have any question about that one? Okay, let me scooch to the other one. Now, I'm going to do the same thing. This graph, I'm going to graph the related quadratic, which would just be to substitute y in place of the 0. And all we're going to do to answer the question is figure out what y value would set the equation equal to 0, and it's just going to be where the graph crosses the x-axis. Now, this guy is in vertex form. So you can see the vertex from the actual equation. Can anybody raise your hand? Tell me, what's the vertex for this graph? Do you remember doing this? What would my vertex be? What do you think? Yes, ma'am. Bless you. Opposite, copy, 5, -8. All right. What would the pattern be here that I would want to use to graph some more points? What would my pattern be? 2, 6, and 10. There you go, 2, 6, 10. If you forget, all you got to do, take your a value, let me grab a different color here, take your a value and multiply it. The a value in vertex form is just right in front of the parentheses. Take your a value, multiply it by that 1, 3, 5 pattern. That's how it alters how you would graph the parabola. So this one would be 2, 6, 10. All right, so let's find, where's 5, -8? Gosh, I've got both of these kind of close to the bottom of the graph here. Okay, so there's 5, -8. So for this one, always over 1 on either side and then up or down the pattern. So I'm going to go over 1, go up 2, and then go over 1, up 6. And I promise you, if I'm asking you to graph this by hand, it should touch the x-axis on nice values because I don't want you to have to estimate anything. So there's other ways to do solving of a quadratic if it's not a nice number. So if I'm asking you to graph it by hand, it should be a nice x value when you find your answers. And then all you're looking for, these 2 x values, right? I've got one at 3 and one at 7. And I'm not on the screen, sorry. Is anybody having a question? Okay. Now, you guys, we're going to need graphing calculator for the back side of this. So if you want to grab your graphing calculator, I'm going to show you how to do this. You're going to graph the related quadratic. These questions are not going to have nice answers a lot of the time if they're asking you to use a calculator, or maybe we'll use Desmos if we want to use that too. So what I'm going to do, first, set this equal to 0 real quick. So I'm going to subtract the 6x. And in this scenario, when you set it equal to 0, if you're using your calculator to solve, you don't have to have the squared term be positive. That's not necessary. It's totally up to you. I'm just going to keep the squared term where it's at, and I'm going to write this in standard form. So to set that equal to 0, be 3x squared minus 6x minus 5. Now, if you sat here and tried to factor this, you're not going to find factors that would be -15 that add up to -6. You can't use factoring to solve this. This has really gross answers. So we're going to use the calculator to solve this. What we're going to do is graph the related quadratic, which we're just going to type the 3x squared minus 6x minus 5 into the y equals on our calculator. Okay, so I'm going to grab my calculator real quick. And you guys, to type this equation in, we're just going to go to the very top left corner, just the y equals right there, top left. And you might have something in here. I have something in mine. And I'm just going to clear that out real quick. And I'm going to type 3. And then just to remind you, because I feel like we haven't done this in a minute, if you're going to type in a variable, the x, it has to be this little button here, this x theta n, right next to the alpha button. That's your x. So I'm going to type my x. And then to square it, if you guys, right by the 7, right diagonal point 7, right there, there's the squared button. You got to type the x first. So I'm going to square it, and then I'm going to do minus 6x, and then minus 5. And move this back. Ooh, this does not look good. Hang on. That's making it better or worse? There, we can see it a little bit better. Okay, now let's go ahead and hit the graph button, the very upper right. And I maybe would, here, I'll tell you what, let me do one thing first. I'm going to hit my zoom and then zoom 6. Zoom 6 is just -10 to 10, just so I had the same window as you guys. So if you want to hit zoom 6, zoom standard just makes the x's go from -10 to 10, the y's go from -10 to 10. That's usually a pretty good idea. Okay, now, once you've got your graph in here, you should be writing down these directions. All right, once you have your graph in, we've used this menu before, but this is a little bit different. You're going to hit second, and then the trace button, which that's going to be your calculate menu. So I'm going to hit second, trace. And then what option do you think we should pick here? The 0, right? Okay, now I'm going to tell you, this is weirder than finding an intersection, which we've done before. Okay, so 0. Now, brings you the little cursor guy. So, if you look at the bottom of the screen here, it says left bound. So I'm going to do this one first, the one that's farther to the left. You need to approach it from the left side. All right, so I'm going to move the cursor just somewhere, just using the left and right. Don't use the up and down arrow keys. Just use the left and right arrow keys. I'm just going to kind of hold it down. I just need to be above the x-axis. Okay, now I know this looks like I'm going to come down when I'm doing this, but I'm coming from the left. So anywhere above the x-axis is approaching this 0 from the left. So just anywhere above the x-axis, just hit enter. And depending on your calculator, you might see like a little line pops up, or you might see a little arrow that pops up here. Mine's kind of on my parabola where it's at, but just it might do that. That's fine. Then it'll say right bound. Okay, now here's all you have to do. I'm just going to move the cursor on the right side of that 0. You just need to be underneath the x-axis somewhere. Just right under. It doesn't have to be real close to it. Just right underneath. So the calculator will go in from these two sides, from left and right, and find the 0 there. So just anywhere on the right side, it says right bound at the bottom of the screen, just hit enter. And then it says guess. I don't know why it says guess. Just hit enter one more time, and it'll go right to that value. Now, you can see this is not a nice number, but it does have a y value that's 0. So if it's not a nice number, the questions are just going to ask you to round to the nearest hundredth. So one of my answers here, I'm just going to put negative, 0.63. That's one of my answers. And to get the other one, we're going to repeat the process. So there's another 0 over here. So I'm going to repeat the process. I'm going to hit second trace, 0. All right, now I'm approaching this 0 here. So I'm going to move my little cursor guy. As I'm approaching this, I'm coming from the left, right? My little cursor's traveling from the left. Just keep going. I'm just trying to get, whoa, too far, sorry. You got to be underneath the x-axis. I'm going to approach this from the left. So left bound, anywhere just like right below the x-axis, hit enter. And then again, it'll pop up this little arrow. This is where it's going to start. Then it says right bound. Just come just a little bit above and hit enter. And what you're doing, these two little arrows, if they pop them up on your screen, you're telling the calculator, look between here and here for the 0. That's what you're telling the calculator. It'll say guess, but we don't want to guess. We want it to do it for us. So just hit enter one more time, and then it should go right to that 0. And sometimes the pixelation's weird, like the y there is 0.12 zeros and a 1. So this is 0, but just round that to the nearest hundredth. So your other 0 there is about 2.63. So not nice numbers. Is anybody having a question? Now, I'm going to have you guys look at what we did yesterday, actually. And solve a system by graphing. So let's review how to do this on the graphing calculator. If you want to use Desmos, you can too. I just can't let you use Desmos on the tests and quizzes, so that's why I want to practice with the calculator too. If you want to go back into your y equals, if you guys remember doing this, just type in your line. So you got negative 2x. When you type in the negative for the 2x, make sure you use the negative key. Don't use the subtraction sign. It doesn't like that. And then the quadratic there, I've got x squared minus 13x, and then plus 26. All right, does anybody remember like what to do next to solve a system on the calculator? We haven't done this for a little bit. Yes, okay, so that same menu. Second trace, we're just going to do an intersection here. That's the only difference. So you don't have to go to left side, right side. You just do intersect. So just hit enter. And it should take you to the screen with the line and the parabola. Okay, now, you might alter the screen a little bit if you want to, but if you can, like, mine looks like, you gotta be able to see the intersection on the screen. This one looks really far down to the bottom. So what I might do, just let me do real quick, I'm just gonna go into the window here, and I'm gonna make the y values go a little bit lower. So my y minimum, it was at negative 10. I'm going to make the y values, maybe, let's make it go to negative 20, just real quick. Because I got to be able to see the zeros on the screen to be able to use the calculator to get those intersections. So, or not the zeros, I'm sorry, the intersections. So I just changed the y minimum. I just went to window, it's right next to y equals, changed it so the graph will go a little bit lower. Because I got to make sure that I can see the intersections on the screen. So once I did that, I can see both of them. You're just going to hit second trace, and then you want the intersection. Now, again, just use the left and right arrow keys. You don't have to do anything really hard here. Just move the arrow as close as you can to, it doesn't have to be right on top of it, but as close as you can. It'll say first curve, which just means it's on the line. Hit enter. Then it'll say second curve. That just means it's on the parabola. Hit enter. And again, I don't know why it's programmed to say guess, but just go ahead and hit enter. And that'll give you that intersection point. So this guy's at 2, 4. And then similar to what we just did, you've got to completely repeat the process to find the other intersection. So just go back, second trace. You want the intersection this time, not the 0. So number 5. And then I'm just going to hold down my right arrow key. I just got to get closer to the other intersection point. It doesn't have to be right on top, but just as close as I can. And then basically once you're there, you're just going to hit enter 3 times, and it should tell you that point. So this is at 9 and negative 10. So those will be my two, that 10 looks weird, sorry, but those would be my 2 answers. Is anybody having a question about finding the intersection for a system on a graphing calculator? Okay, now I have one more problem. And forgive the diagram, it's kind of goofy looking. All right, so this says graph shows a function modeling the height of one frog's jump. Here the x-axis across here is the distance in feet from the jump start. And y here is going to be the height. So if we find any coordinate points here, like our x-coordinate is going to be the distance, and the y-coordinate is going to be the height. How would I figure out, this gives you, and this formula is not great. We're going to use the graphing calculator for this. So here's our formula we're going to use here in a second. How would I figure out how high the frog jumps? Like, what would I be looking for? The vertex, right? Okay, so specifically, I'm going to look for the y-coordinate of the vertex. Okay, now, 2 options here. You guys could do this by hand. You could do the negative b over 2a and plug it in, or I'm going to show you how to do this on the calculator real quick. So I'm going to go to y equals, and I'm just going to get rid of that system we were just using, so I'm just going to clear those out. And I'm going to type this function that they give us in the diagram. So this is negative 0.029 x squared, and then plus 0.59. You don't have to put the 0 in front of like 0.59. You can just put 0.59 and then the x. All right, we might have to move the window around here, so let me graph this and see what it looks like. Okay, let me do, I'm going to kind of mimic the graph that they have on the screen here. Let me go into my window. All right, so I'm just right next to the y equals to do this. I like to see both sides of the x and y axis, so what I might recommend here, let me just make x like the minimum. Let me make it -1. You can manipulate this however you want. And then, I don't know, maybe, I don't know how many, let's make the x maximum go over to like 20. We can always go back in and change it if this doesn't give us a good picture. All right, and then for the y minimum, I'm going to kind of do the same. They just show you just a little bit. I'm going to go -1 here for the y minimum. Use the negative key, not the minus sign. And then, what is 1, 2, 3, 4, 5, 6, 7. Maybe I'll go up to like, I'll just put 12 there. You can put whatever, you can make it bigger if you want to. I'm just going to try to see if we can get a good idea of the path. And then I'll hit graph and see. Actually, I'm going to go back in just 1 second. I'm going to make it go a little bit farther on the x. So I'm going to go back into my window. I'm going to make my x maximum like 25. And I felt like that my y values were too tall. Maybe I'll put that back down to like 10. Whatever. Okay, so this is a mimic of that graph that we've got on the screen. You can manipulate this if you need to. But I want to show you how you can find y-coordinate of the vertex using the calculator real quick. All right, so same menu. We're going to hit second trace, if I can spell trace. All right, and then if I want to find the height that the frog reaches, the maximum height, which one of those do you think I'm going to pick? There you go. Okay, so number 4 here, the maximum. Okay, this is similar to the zeros. So it'll say left bound. So what you want to do, just use your little cursor, just come somewhere, it doesn't matter where, just somewhere on the left side of where you think the vertex is. All right, left side. So just somewhere on the left side, hit enter. And then just hold that down. I just hold down the little right arrow key. Just move somewhere on the right side of where you think the vertex is. It doesn't have to be exact. And some of the calculators do this, some of them don't. They might pop up a little line, or it might pop up a little arrows or both. You're saying to the calculator, look between here and here and tell me where the maximum is. Again, across the bottom it says guess for some reason. Just hit enter, and it's going to give you the maximum there. Now, the x value is going to be your distance, so you don't need that. How high did the frog jump? What would you tell me your answer would be? 3. And I can't remember what this is. This is in feet. So 3 feet. Okay, how would I figure out how far the frog jumped? If x is the distance, how would I figure out, like, here we go, we're jumping, we're going to land back down on the ground here. How would I figure out how far that would be? What would this point be? A 0, right? Okay, so we did this at the beginning. That's why I moved the graph out a little bit. This is just going to be x coordinate of this point right here. That's what I'm looking for, the 0. So what we're going to do, just that same menu, I'm going to find the 0. So we're going to do second trace, and from that I want the 0 this time. All right, so this is going to be like that very first question where we have to go left side, right side. So I'm just going to keep going over here just a little bit. As I approach this 0 from the left, you just have to be above the x-axis. Sorry, it's going slower on here than it is on my calculator. Okay, just above the x-axis, hit enter. And then just go, bless you, just go below the x-axis. That's somewhere on the right side of that, hit enter again, and then you're good. It'll go right to it. Now, we're just, if these are not nice numbers, just go ahead and round to 2 decimal places. So I would say 20.34 feet for that one. All right, and then just related to what we just wrote down, I'm just going to ask you a quick question. If you're looking at that graph, what would you tell me for this frog's jump, which the x values for the domain are going to cover the frog's distance, what would you write down as a domain for the frog? What do you think? Good deal. Okay. He starts on the ground, jumps. So he's going to start no distance from his starting place, right? Because he's starting. And then he's going to jump, and he lands 20.34 feet away. And I would put brackets on both of those because you would touch no distance, and then you would also touch the 20.34. What would you tell me for a good range for the frog? So that would be the possible heights that he's at. What would you write for the range? What's the lowest height the frog's at? 0, right? Is on the ground. What's the highest height that he reaches? 3 from the vertex, right? So just 0 to 3. Everywhere else is in that range. Is anybody having a question? Okay, now the homework is on paper, and if you want to use Desmos, I totally understand Desmos is so much more user-friendly and quicker to use, and I completely understand that. But make sure you try and practice with the graphing calculator as well to find the zeros. And if you need any help, let me know. But if you do want to use Desmos, Desmos should give you the same answers as the calculator does. It's just that I can't let you use it on a test and quiz, otherwise I would let you use it all the time. If anybody needs help with the calculator, let me know. If you want to just put your graph back to a normal window, just hit zoom 6, and that'll put it back to a normal -10 to 10 on the x and y. Six and 7 are like the very first example on the back page.